So my idea here in this video is to walk you through a little bit of what I'm doing in the back end. In Excel, I'm going to walk you through two examples. One of the examples is the data set that we did in class in our computational video, just using the values of 1, 2, and 3. And then one's the more sophisticated example using our ID for 20 different participants and a math scores with 20 values. So let's go ahead and do the simple example first. We're also going to do this with using some of Excel's features. We're going to do it two different ways. We're going to calculate out means and variances in a couple ways. So first, just to recall this is my variable. This is an identification variable for person 1, 2, and 3. We could have changed these names, right? This could be, different person's names instead. Right, so this could be a naming variable. I just called it ID. And this is the actual data. So Will would have scored a 1, Sarah would have scored a 2, and Lisa would have scored a 3. My next table, I just calculated out some of our measures of central tendency in Excel. There's going to be two ways to do that. So if you're familiar with this way, that's great. I'm just using some cell features in Excel, but also stick through the video because I'm going to show you how to use a little bit of the data analysis tool as well, even if you're not interested in this feature. So here I just calculated out the mean. I could have done this the long way. I could have taken the values 1, 2, and 3, added them together, and divided by 3 and gotten 2. But also Excel has some nice little features here. So in the cell, I can tell Excel the value for this cell is going to equal the average and for the cells that I'm putting it in. If there's a missing cell here, it just default doesn't calculate it. So here I'm asking for the values of 1, 2, and 3 to be averaged. And that's what I got. This also, another feature, here's another little bit of code here in Excel asking for the median, which is also 2. The middle point here we can see, ordering these, the middle point is 2. The mode comes up with NA because it's a flat distribution. That's always going to happen whenever you have a flat distribution. So really there's no mode here because our distribution, there's only one value of 1, one value of 2, one value of 3. So I just placed up here the mean for each one of them so I could do a little subtraction to get our deviation scores. So our deviation scores, we did this in our computational video. We know our deviation scores are just the value for x minus the mean. So here we can see I asked for cell B2, which is this blue cell, minus C2, which is this red cell. That gives us our deviation score. And I did that for each one. So here's for 0, and here's for person 3. They ended up with a 1. And then square all those values. So now these are my squared deviation score. So I took -1 and squared it in Excel. Squaring a value is just this little carrot looking thing to the second power. So I squared all these values, and then I summed them. So this cell represents the sum of my squared deviation scores. N, I have 3 people, and -1 is 2, so that's where 2 comes from. You take 2, take those 2 cells and divide them, you get our variance. I could also calculate variance, in this case variance for a sample in Excel, by using the variance function here. var.s is for a sample. If I wanted to do that for a population instead, I could have just called it p for a population, which I get a different value, because it'll take that value here and divide it by 3. Instead of n-1, it'll divide it by 3. So a lot of these features here, if you're interested, that's great. If you're not, that's okay too. I'm also going to show you how to do this too, some of these things through the data analysis tool. I'll show you one other thing which is useful here, which is also I calculated out z-scores. All I did to calculate our z-scores, really now that I have a deviation score for each one of these, I know that our z-score is really a deviation score divided by the standard deviation. So I just put the standard deviations here, my deviation scores here, and my z-score is just the deviation score divided by the standard deviation. Because if you recall, our z-scores were just the mean, the x minus the mean, which is your deviation score, divided by the standard deviation. So I did that to calculate each one of my z-scores. Interesting. But that's not the only thing I want to show you. Let's go back to just the really simple example without all of this kind of clutter. There we go. So I have a data set. I want to do some calculations on it. I want to do some analysis on this data set. I'm going to go ahead and go to the data analysis program here. This data analysis tool in Excel. I can use descriptive statistics. Notice there's some really other cool stuff. We're going to talk a little bit about ANOVA and t-tests and maybe some other types of tests in our inferential statistics video. But we're just going to focus on descriptive statistics here. So I'm going to select descriptive statistics and click OK. I'm going to tell it the range that I'm interested in are just these values in these cells here. I just highlighted those. And I want to make sure summary statistics may or may not be checked off. And this time I just verified that it is clicked on. And I'm going to ask for it in a new worksheet. I'll go ahead and click OK. Now look, I got all my nice values for my mean, my value for my median, my standard deviation is here, my sample variance. There's some other values here as well. Our skew or kurtosis, a value for a standard error. But those things that I calculated out using some of those other cell level features in Excel, all I did, I didn't have to know really any of those features. This is all just GUI interfaces. I just selected data analysis, clicked OK, selected the data that I was interested in, and did some descriptive statistics for that data. And just redid it again. Now, why am I showing you that also is because we can do this for some of our other data set. So I'm going to go back to our other data set. I'm going to walk us back through this. I used this as a partial example in our lecture. We had our data. We calculated out a mean. We could take all of these values and divide by the total. There's 20 data points here. In Excel, I could use the average feature to calculate out the mean, the median feature to calculate out the median, and to calculate out the mode. I use the mode multimodal, but that's, that's okay. So here, a better way of looking at this is the same data, just organized better. So I now have a value of ID. So I now have person 1 through 20. I have persons, my outcome variable, my dependent variable, or just maybe the variable I'm interested in exploring here, math test, and that's from values of 49 all the way down to 92. We'll take a peek at, let's go to our, I'll come back to histograms in a moment, but let's go ahead into our data example 3. Just covers our variance components. So we calculated out the variance in Excel this way and our standard deviation. So first thing I'm going to do is go ahead and show us the data analysis feature here. I click on data analysis, click on descriptives. I'm going to select and highlight the area I'm interested in. I'm going to ask for summary statistics. And I'm going to ask for it in a new worksheet. Click OK. So we can just kind of go back and forth with this data. Actually, I'll just copy this and paste it right here just so we can do a little side-by-side comparison. So we can see the mean just by pointing and clicking using the GUI interfaces in Excel. I calculated out a mean of 73.85. Our median and mode are both 74. And one thing here is that didn't account for a multimodal distribution because we have 3 values of 74 and 3 values of 80. That's okay though. Our standard deviation was calculated out the same, and so was our variance because it's for a sample. Here we also got values of skew and kurtosis. There's like to see, we won't go into values we really would like to see, but values around 0 for Excel look pretty good here. We calculated our range. It's the same as this. our minimum and maximum values. So just by using the data analysis feature in Excel, it's a pretty powerful tool. So, a lot of people say use SPSS and SAS. I'm a big SAS user, a big R user myself. But when you're just starting to learn, it's okay to learn and use all this stuff in Excel. And there's really nothing for us in our class that we'll do that will go beyond what we'll need Excel for. I'll just show you, I created a histogram in Excel under Insert, under our charts, under all charts for my version of Excel. I'm going to click histograms. It's going to give me a big histogram, but I'm going to have to go in and change the bins. If you see this histogram looks very different than the one I have here. It's the same data, right? It's just these number of bins really matter. Bins are just their boxes. So here I have just these 3 big buckets it's putting everything in. And here I have all these really narrow boxes. So let's go ahead and change. I think we can do that by formatting this axis here. Instead of asking for, here we go, 3 big bins, we can just actually go ahead and give a bin width of 1. So that's only each individual value will count as its own bin. So 49 will be its own bin, 50 to 51 will be its own bin, 1 to 2, etc., etc. And let's see what we have here. It kind of doubled up on us, but it's the same graphically, right? So we have a 1 value in 49 to 50. We see that here. 1 value 53 to 54. We see that here. Go up to our 70, between 73 and 74. It's calculating 73 here and 74 here. We see that we have that value. We can kind of highlight any of those values and see where they're coming from. We have 3 values. We have 3 values of 73. So, you can get a little bit more sophisticated. I do a little bit more work. I can collapse over some of these axes a little more. I won't go into all those details in this video, but I just thought it might be useful. You can see where I'm getting some of my histograms and my analysis from. Let's just do one more thing. Since we have this open, let's go back to our data. I'm just going to, John, Todd, Sue. So let's just say I collect up some more data from folks, and I have values of 3, 2, and 4. I just made up some new data. Now we have a data set of size 6. We have our naming variable, our identification variable. I could call it ID if you all prefer. And then I have my value here of X. Instead of calling it X, I could call it Y if I wanted to. I could also give it its proper name if this is my math quiz. Whatever I want to do is my naming convention. So now I have 6 data points instead of 3. I can go in under analysis. I'll still do a descriptive analysis. Click OK. I'll specify my values. Make sure it knows summary statistics. I could select an output range here. Tell it to place some of my output here. Go ahead and click OK. And now what's kind of neat is I've done the analysis on a new data set. I've just added new data to this. I get a new mean, a mean of 2.5, new median. Now I actually have a mode. We can kind of go through and see actually I have a multimodal situation again here. I get a variance. It's a new variance for this new data set and a standard deviation. So for those looking to do a little bit of computation, or if I ask you to do something on a quiz or your final and you don't want to do some of it, I put finger quotes here, doing it by hand. If you don't want to do it sort of the long way in Excel or a calculator, you can use any sort of resources that you have available to you, whether it's Excel, whether you know some other software packages like SPSS, R, or SAS. I'm very happy for you to do any analysis that I might ask you to do in any package that you're familiar with. But now you're a little bit familiar with Excel.